Welcome student, how are you? I am Dr. Maji, it is physics for NEET, mains and advanced. Today I will be discussing on equilibrium. Now first of all look at this problem. A mass 10 kg suspended by means of three strings. We have to calculate the tension T1, T2 and T3. Now here mass 20 kg is suspended by the two strings, this and this. We have to calculate tension T1 and T2 and force F acting along this direction. Now in this problem, load 100 kg is connected this way. We have to calculate T1, T2, T3. And look at this problem. Look at this here, 10 kg suspended and 20 kg on the inclined plane, and we have to calculate the mass of it so that the whole system in equilibrium. Now first of all equilibrium. If a body is at rest or uniform motion in a straight line, then the body is said to be in equilibrium. That means the body has no linear and angular acceleration. If the body has no linear or angular acceleration, then net force acting on it 0 and tau net torque acting on it 0. For coplanar forces, the vector sum of the forces along x-axis is 0 and vector sum of the forces along y-axis is 0. Okay, and torque 0, that means anti-clockwise torque equal to clockwise torque. Now look at this, first of all this problem. Look at this, we have to draw the free body diagram of 10 kg. Look at this. What is the free body diagram? What is the free body diagram of 10 kg? Look at this. This is the 10 into 10. This is the 100 Newton, and this is the tension T1 upward direction. As the body will be in equilibrium, so sum of the forces along y-axis is 0. Therefore, T1 equal to 100. So T1 equal to 100 Newton. This is number 1. Now we draw forces acting on this part. Look at this. Here, this is the tension T1, this is the tension T2, and along this direction, this is the tension T3. Okay, look at this angle 37 degree. So this angle becomes 37 degree. Okay, and this angle 53 degree. Okay, 53 degree. So this angle becomes 53 degree. Okay. So this angle becomes 53 degree. Okay, now we have to resolve T2 and T3 along horizontal direction and vertical direction. Now look at this, the component of T2 along this direction, T2 cos 53 degree, and this direction is, look at this, T2 sin 53 degree. Okay, now next, and component of T3 along this direction, T3 cos 37 degree. And this is the T3 sin 37 degree. Okay, now look at this. So this forces, so sum of force along this direction and this direction are same. So look at this, T2 cos 53 degree equals to T3 cos 37 degree. Okay, now put the value here. T2 cos, look at this, T2 cos 53 degree, that is 3 by 5, and T3, this is the 4 by 5. Therefore T2 equals to 4 by 3 T3. Okay, now next, look at this force and this force, upward direction and T1 downward direction. So look at this is the T2 sin 53 degree plus T3 sin 37 degree. This equal to T1, and T1 means this is the 100. Okay, now T2 equals to 4 by 3 T3 into sin 53 degree, that is 4 by 5, plus, look at this is the T3 into 3 by 5 equals to 100. Okay, now LCM is 15. Look at this is the 16 and this is the 9 and this is T3. This equals to 100. Therefore, T3 equal to, look at this, 100 into 15 divided by 25. So this is the 60 Newton. And if T3 60 Newton, then T2 equal to 4 by 3 into 60, that is the 80 Newton. Okay? Understood? This discussion helps you a lot. Please like, comment and share the video. And if you are new, please subscribe my channel. Now next problem. Look at this, the free body diagram of 20 kg. What is the free body diagram of 20 kg? Look at this. This is the 20 into 10 Newton in downward direction and T1 in the upward direction. Okay? So 20 kg is in equilibrium. Therefore, look at this. T1 equals to 200 Newton. Okay? Next. Now we calculate the forces. Now we draw the forces acting at this point. Look at this here, horizontal force F, and this force is T2. Okay, and this is the T1. Okay, now look at this. This angle is 30 degree. So this angle is also 30 degree. Now component of T2. Look at this. Component T2 is T2 cos 30 degree, and this is the T1 sin 30 degree. Okay, here look at this. Therefore T2 cos 30 degree, this equals to T1, and T1 means 200. So T2 into root 3 by 2, this is the 200. So T2 equal to 400 by root 3 Newton. Okay. Now next F. Look at this. F equal to, look at this. F equal to T1. Here, look at this. Here, F equal to, look at this. Here, F equals to T2 sin 30 degree. Okay. If T2 sin 30 degree, so here look at this. T2 equals to 400 by root 3 into 30 degree. This is the half. So this is the 200 by root 3. Okay. So force acting on it is 200 by root 3 Newton. Understood? To boost up your NEET or advanced preparation, don't forget to subscribe my channel. Now next problem. Look at this, the free body diagram of 100 kg. Look at this. This is the 100 kg. So here force acting along this direction 100 into 10 Newton. Force is 100 into 10 Newton directed along this direction and T1 up this direction. So look at this here. T1 equals to 1000 Newton. Okay. Now consider this part. The forces acting on this part, look at this. This is the T2 and this is the T1 and along this direction is T3. Okay. Now look at this. This angle is 53 degree. If this angle is 53 degree, look at this. If this angle is 53 degree, so this angle also 53 degree. Okay. Now the component of it along this direction T2 cos 53 degree, and this is the T1, so this is the T2 sin 53 degree. Okay. Now this force equal to this force and this force equal to this force. So look at this. T2 into sin 53 degree. So this is the 4 by 5 and this equals to T1 and T1 equals to 1000. Okay. Therefore T2 equals to 1000 into 5 by 4. Okay. So this is the 1250 Newton. Okay. Now we have to calculate T3. Now T3 equals to, look at this. T3 equals to T2 cos forces along this direction equal to forces along this direction. So T2 cos 53 degree. Now look at this. This is the T2 equals to 1250 and cos 53 3 by 5. Okay. So look at this. This becomes 750 Newton. Okay. Understood? Please like, comment and share the video. Okay. Now look at this. Look at this. Look at this here. Tension here 1. Look at this here. 5 strings connected here. We have to calculate. Look at this. Look at this here. 5 strings connected here. We have to calculate the T1, T2, T3 and T5. Now first of all, look at this. The free body diagram of 100 kg. Look at this. This is the 100 into 10 Newton acting downward and T1 upward. So look at this, T1 equal to 1000 Newton. Okay, forces acting at this point. Look at this, here forces acting is T3. Look at this, here forces acting along T2 and here forces acting along T1. Okay, now here angle, this angle is 30 degree. So component of, look at this, the component of T3 along this direction, this is the T3 sine 30 degree. And this becomes, look at this is become T3 cos 30 degree. Okay, now this force equal to this force. So look at this, T3 cos 30 degree, this equals to T1 equal to 1000. Okay, so T3 into cos 30 means root 3 by 2, this equal to 1000. Therefore T3 equal to 2000 by root 3. Okay, now we have to calculate the T. Look at this, T2 equal to T3 sine 30 degree. Look at this, T2 equal to T3 sine 30 degree. Now look at this, here T3 is to 2000 by root 3 and sine 30 is equal to half. So this is the 1000 by root 3 Newton. Okay, now we have to draw the forces acting at this point. Okay, now look at this. Look at this, here forces acting on T3. Look at this, here forces acting on T3 along this direction. Here forces acting on T5 along this direction, and here forces acting T4 along this direction. Okay, now look at this angle, look at this, this angle 60 degree. Okay, this angle 60 degree. And here look at this angle is 30 degree. If this 30 degree, so this also 30 degree. Okay, now look at this, we draw the forces acting at this point. Look at this, this is the T5, this is the T4 and the T3. This angle 30 degree, so this also 30 degree and this angle 60 degree. Now we resolve T3 along this direction, so this is the T3 cos 30 degree and this is the T3 sine 30 degree. Okay, now look at this, here look at this, here T5 component of this direction is T5 cos 60 degree and this is the, look at this, and this is the T5 sine 60 degree. Okay, now forces acting in upward direction is equal to forces acting in downward direction. So look at this, T5, look at this, T5 cos 60 degree, this equals to T3 cos 30 degree. Okay, so look at this, T5 into half equals to T3 cos, this is the root 3 by 2. Now T3 equal to, look at this, T3 equal to 2000 by root 3. So look at this and this cancel out, so T5 equals to T3, that is 2000 by root 3 and this is also root 3, so this is the 2000. Okay, so T5 equal to 2000 Newton. Okay, now look at this here, forces acting on T4 and T3 sine 30 degree and this direction is T5 sine 60 degree. Now look at this, from this condition, here T4 plus T3 sine 30 degree, this equals to T5 sine 60 degree. Now put the value. Look here, forces acting on a T4, T3 sine 30 and T5 sine 60. Look at this, T4 plus T3 sine 30 equal to T5 sine 60. So T4 plus, this is the T3 into half equals to T5 into T5 into root 3 by 2. Okay, T5 into root 3 by 2. Okay, now put the values up. Look at this. Here T4 plus T3 T3 equals to 2000 by root 3. So this is the 2000 by root 3 into half equals to T5. Look at this. The value of T5 you already gets root 2000 to 2000 into root 3 by 2. Okay. Now look at this. This is the T4 and plus this is the 1000 by root 3 and this is the 1000 root 3. Okay. Now this becomes T4 equals to, look at this, 1000. Okay. This is the root 3 minus 1 by root 3. Okay. So this is the 1000. Look at this, 1000 into 3 minus 1 by root 3. Okay. Therefore T4 equals to, look at this. This is the 2000. T4 equals to 2000 by root 3 Newton. Okay. So look at this. Here T1 equals to, look at this. Here T1 equals to 1000 Newton. T2 equal to 1000 by root 3 Newton. T3 equals to 2000 by root 3 Newton. T4 equals to, look at this, 2000 by root 3 Newton and T5 equals to 2000 Newton. Okay. Understood? Now next, look at this. This is the 10 kg acting vertically downward, and this is the 20 kg along the inclined plane, and we have to calculate the mass in this block so that whole system in equilibrium. We have to calculate also T1 and T2. Now first of all we have to draw the free body diagram of 10 kg. Okay. Now we have to draw the free body diagram of 10 kg. Look at this. For 10 kg, here 100 Newton acting vertically downward and T1 upward. So look at this. T1 equals to 100. Okay. The free body diagram of 20 kg. T1 acting along this direction, T2 acting along this direction, and 200 sin 30 degree acting along the plane. So look at this. This force plus this force equal to this. So look at this, T2 equals to T1 plus 200 into 1 by 2. So T2 equal to T1 equals to 100 Newton plus this also 100 Newton. So this is the 200 Newton. Okay. Now look at this, the free body diagram of M. Look at this. Here force is acting on M into G downward direction and T2 in upward direction. So T2 equals to M into 10. Now T2 equal to 200 Newton. Okay. So this is the M into 10. Therefore M equals to 20. Okay. I hope this video will be beneficial for you. Please like, comment and share. I hope this video will be beneficial for you. Please like, comment and share the video. And if you are new, don't forget to subscribe my channel for further update.